Mm. Hello guys, welcome back. I hope you watched the previous video. In this video, let us learn about routing policies. So, what do we learn in this video? In this video, let us learn and discuss about routing policy. So, in order to move to it, why do we need to learn about this routing policies? So, let us move back a bit. That is, whenever we create a hosted zone, what happens? We have multiple types of records. We have many records, right? Yeah, many records will be created. So among those, we have name server record and SOA records are there. So what this name server record will specify as? It will specify as our DNS server in my hosted zone. So only one DNS server is available? No, right? We have multiple servers. So we have multiple servers. So based on request and based on some algorithm or methodology, our request will be forwarded to any one of the server, right? Yeah. So in order to maintain these many records, so to forward our request to multiple servers or multiple NS servers, we need to maintain multiple NS records, right? Yeah. So here, if you consider about Route 53, here this Route 53 will create you how many NS servers? 4 NS servers and 1 SOA record. So among these 4 NS servers, if you consider for one application, so it has 4 NS servers. So in order to route the traffic between these name server records, or in order to define the route to your DNS query, we need to look at this routing policy. We have multiple routing policies. So let us look at one by one about these routing policies. So let us define this. What is this Route 53 routing policy? What does it do? It defines how to answer any query. It defines how to it defines how to answer to a DNS query. So it defines how to answer to a DNS query. Each type of query has some different DNS, some different routing policy. So let us see one by one among. Simple routing policy. This simple routing policy will randomly choose a record. So let's say you're having multiple A records. This simple routing policy simply routes your traffic randomly to any one of the record among multiple A or A records. A record specifies IPv4 address to your domain, whereas this 4A's record specifies IPv6 address for your domain name, right? Yeah. So let's say I have two A records where they are holding an IP address of 27.81.59.0. So like this, one IP address is there, and another IP address is there with like this. In a similar way, it is also having multiple records. This is IPv6, right? IPv6 have more more bits. So this is A record. This is IPv4 address. So let's say you are having multiple A records. That means multiple IPv4 addresses which are mapped to your host name. So while discussing about record types, we have discussed when do we use A record and when do we use 4A's record. If you want to map your host name to IPv4 address, then we use A record. Let's say you have multiple A records. That means multiple mappings to your IPv4 address. That means if you have more than one server, then what happens? You got different IP addresses for each and every server, right? Yeah. Or else if you host different elastic load balancers for your application, this is one region elastic load balancer and there is another region elastic load balancer. like that you are having multiple elastic load balancers. Then what happens? You obviously have multiple IP addresses, right? So in that case, what you do? You need to route your client's traffic to your elastic load balancer. But you are having multiple elastic load balancers IP addresses. Then how to route the traffic among those? So in order to route the traffic among those, this simple routing policy is one of the method where we can able to route the traffic. How? Randomly. If you want to route the traffic randomly, then you choose this simple routing policy. In this simple routing policy, it will route the traffic among whatever the records that you provided. So among those, your routing, your request routing will be happen randomly. One more important point, regarding to this simple routing policy is it does not support health checks. Whereas other routing policies will support health checks, but the simple routing policy does not support health checks. So this is one of the important point that you need to consider while using this simple routing policy. When do you use this simple routing policy? Whenever you are having multiple records, multiple A records or multiple A records, then in order to route the traffic among them, if you choose to route randomly among them your traffic or DNS request, then you choose the simple routing policy. Once again, I am telling you, it does not support health checks. Now, the second one, that is weighted routing policy. So if you prefer this routing policy, then what happens is your traffic is routed based on weights. Based on weights you specify to records. So based on that, your traffic will be routed among records, and then based on the record your traffic is routed, then the query is transferred to that particular corresponding IP address which is holded in that record. So indirectly, this weighted routing policy will route your traffic to IP addresses only. So based on whatever the weight that you specified for the record. So here we need to specify the weight for each and every individual record. Let's say you have these three A records that you stored. Okay. Now you assign the weights for these three. So for the first one, you assign the weight of 10, and for the second one, you assign the weight of 0, and for the third one, you assign the weight of -1. So remember one more point while assigning the weights, you need to assign the weights from 0 till 255 only. You can assign positive weights from 0 to 255 only. Whereas you can assign 0 weight also, you can able to assign negative weights also. So how the traffic is routed? Traffic is routed based on, traffic is first routed to non-zero weights. First your traffic is routed to non-zero weights. So traffic is routed first to where? To non-zero weights. Then it will route, then it will route to, if there is no non-zero weights, then only it will route to 0 weights. Otherwise it won't. So now you can see how traffic is routed among non-zero weights. So how it will be routed is based on weight. So what are the weight you specified by 255? So based on the value that you got, those many requests will send to that weight. Here you can see 10, which is the highest positive value. So this will get higher number of records. This will get higher number of requests. More number of requests will send to this A record, this first A record, because it is having weight of 10. That means the weight of 10 is assigned to this record. So more number of requests sent to which IP address? This IP address. And you can see here -1, which represents less weight. That means very less number of requests will send to this particular record or this particular IP address. Less number of requests sent to this particular IP address. So first these two will be considered. Then after that, first non-zero records will be considered. After that, then only zero records will be considered. So if all records with weight greater than 0 are unhealthy, so let's say this becomes unhealthy. This becomes unhealthy and this also becomes unhealthy. So let us write here that point. So whenever all non-zero records will become unhealthy, all non-zero records will become unhealthy, then only your request will be routed to zero weight records. That means then only your request will reach to this IP address. That means this servers. So in weighted routing policy, your request will be routed in this way based on weights. First, it will be routed to non-zero weights, and then among non-zero weights also, it will route to highest positive value record. More number of requests, it will route to highest positive record. Then it will route the traffic, less traffic to lowest number of weight records, IP addresses. And whenever all your positive weights or negative weights, non-zero weight records becomes unhealthy, then only your request will be routed to where? Zero weighted records. So let's say these two becomes unhealthy, then only your request will be routed to this zero weighted record, that is A record. So then your request will be sent to this IP address, and then you got the response from this IP address. So this is how the routing happens in the weighted routing policy. So let us discuss about health checks. So does it provides us the health checks? Yes. This routing policy provides us the health checks as well. This weighted routing policy supports health checks. So this routing policy supports health checks. So if any of the record is unhealthy, then what happens? The process is repeated. The routing process is repeated until a healthy record is obtained. So here it is the advantage compared to this simple routing policy. If any unhealthy record found in this simple routing policy, or your request will be sent to any unhealthy record also, it won't re-respond or resend back to another healthy record to get the response for what are the requests you got. So since here all the requests won't got response, because whenever you request send to unhealthy record, does it provides you response? No, right? Yeah. So here all requests do not got responses. Whereas in weighted routing policy, or the policies which support these health checks can able to provide the response by what? By repeating the process. By repeating the process of routing the request to healthy records, by routing the traffic to records until the record will be healthy. It will route, or it will repeat the process of routing again and again. In this way, this weighted policy are healthy. This health check supporting policies will able to provide the response for every request. So this is the one more important point that you need to consider while choosing a routing policy. So whenever your record will be unhealthy, then if you choose the routing policy which supports the health checks, then what happens is your request will be routed to other records until the record health will be healthy. So if the record health will be healthy, then you got response, right? Yeah. So until the routing process get the healthy record, it repeats the process again and again. Routing policy don't stop the routing of your request. So this is one more important point that you need to consider. The next routing policy is geolocation routing policy. In this geolocation routing policy, this will route the traffic based on customer's geolocation, based on customer's IP address of the geolocation. It will route the traffic. So how does it routes the traffic? It routes traffic. So based on IP address, based on IP address of customer. So it even verifies the IP address of customer's location and routes the traffic to corresponding records. This will route the traffic among IP. This will route the traffic based on IP address of customer location among records. Here, in order to identify the records which are available on particular location or particular continent or particular country, what we use is we use tag records. We use tags for records. We use tags for records. So why do let us highlight the point here in this geolocation routing, based on what your routing happens, based on IP address of your customer. Routing happens among your records. Again, remember the records will be tagged records. That means the tags are attached to your records. Why these tags are attached? So in order to specify, it's a which country it is or which continent it is, or whether it's a default record where it can able to access general type of queries. So that we need to tag for those records. So here provide we need to provide tags to records. We need to provide tags to records. Which type of tags? We need to provide tags like which continent or else which country. So which country or which continent or default record. So like that, we need to provide our tags to our records. So can we say this geolocation routing policy will route the traffic among or distribute the traffic among countries based on the IP address of customer? Yes. So this will route or distribute the traffic among IP address or what are the tags that you provided for the country. So let us see this geolocation routing policy supports health checks or not. So this geolocation routing policy also supports health checks. What? It supports health checks. It supports health checks. That means whenever if any record is unhealthy, then the routing process will repeat until the healthy record is found or obtained, right? Yeah. So that process will be happened under geolocation routing policy also. Now let us see about another routing policy, that is geo proximity routing. So in this geo proximity routing, it routes the traffic. It routes the traffic. Same like geolocation routing only, but it routes the traffic based on latitude and longitude. Based on latitude and longitude. So based on latitude and longitude of customers, location, customers request location, you can say location among records. So what are the records available among those? It will be routed. So based on latitude and longitude. So in order to identify particular record which is having particular longitude or latitude, do we need to provide tags? Yes. So here also we are using tags for our records. So why we are using tags? We need to provide tags to records here. What tags we need to provide to our records is the region tags. So in which region your tag will be, or else in which longitude and latitude coordinate your record will be. Which longitude and latitude your record will be. So those coordinates that you need to provide. So what are the tags that we provide here? In this case, for geo proximity routing, we provide tags like region or longitude and latitude coordinates. We are providing as tags to our record so that it will easily identify those tags and your request will be routed to those tags related records. And then your request again routed to whatever the IP address which is present under those records. Then you got the response for that particular geographic location, for that particular user who is present in that latitude or longitude. You can even able to route your traffic among regions. You can even able to route your traffic among regions in this based on bias. So what is that? Bias. By using bias, you can able to route traffic to one region by using what? Bias. By using bias, we can able to route more traffic to certain regions or to specific regions, and we can even able to route less traffic to specific regions, route more or less traffic to specific regions. So in this bias, what we provide to route the traffic among regions based on our traffic. So what we provide in this? We provide numerical value. That numerical value specifies how much amount of traffic that needs to move to that particular record. Here we'll provide the values from -99 to 99. So based on the positive value that we provide, that got based on the highest value of bias that we provide to a record, that record will get more number of requests. That record will get more number of requests. So in this way, we can able to route our traffic to particular record or particular region. So based on this biasing in this geo proximity routing. Is this geo proximity routing policy supports health checks or not? So this even supports the health checks as well. This geo proximity routing also supports health checks as well. So that whatever the request that you send, that will be must send to any one of the record or any one of the DNS where, or any one of the server where you got the response for your query if you use this geo proximity routing policy. So one more very important point, that is you can able to use this geo proximity routing policy only when you create traffic flow, only when you use traffic flow feature. This is very important point regarding this geo proximity routing. So you can able to use only when you use this, when you use traffic flow. You can use this geo proximity routing policy only when you use the feature, only when you use the feature. What is that feature? Transfer flow. Transfer flow to create, to create traffic, to create tra traffic policy and implement that traffic policy to certain domain. So while discussing about transfer flow, you're gonna get a knowledge of what is transfer flow feature and what is traffic flow policy. So simply remember this traffic flow policy as a policy which contain multiple routing policies, and we can able to manage multiple routing policies by using a single traffic flow, traffic policy. So by using single traffic policy, we can able to manage multiple routing policies. And where these traffic policies are managed is in traffic flow feature, we can manage these traffic policies. So whenever we are using these two, that is traffic policy and attach this traffic policy to any domain, then only we can able to use this geo proximity routing policy. We can able to use that under traffic policy only. So must important, must need to remember this point. If you want to use this geo proximity routing policy, then you need to configure this, or then you need to create this traffic policy. Under this traffic policy only, you can able to provide this geo proximity routing policy. You can create this traffic policy by using what? Transfer flow feature, and you can able to implement this traffic policy by using transfer flow feature only. This transfer flow feature will automatically implement whatever the policies which are attached under this traffic flow policy. So if you put this geo proximity routing policy under this traffic flow policy and you attach this traffic policy to any one of the domain or subdomain, then this traffic flow will automatically create the records and route your traffic based on this routing policy that you provided under this traffic policy. So while using this geo proximity routing, you can able to use it only when you use this traffic policy. So this is about geo proximity routing. In this failover routing policy, the routing will be happened based on health checks among records. So here you need to provide primary, what is the primary record and what is the secondary record. So whenever, if your primary record is unhealthy, so if this health check failed, this health check will tells this primary record is unhealthy. In that case, your request is routed to secondary records. So you need to provide the primary records as well as secondary records in this case for this failover routing policy. Let's say you are expecting to provide the response to your clients with low latency. That is very fast response, very quick response. In that case, you need to prefer latency routing. So you have this type of latency routing policy as well. So in this latency routing policy, what happens is it will route the traffic. It will route the traffic based on low latency, based on the nearest record. So it will routes the traffic based on lowest latency record, lowest latency providing healthy record. So based on the lowest latency providing healthy record, it will route your traffic to that record only. So then you can get a very quick and fast response, right? Yeah. So how to identify a record is the lowest latency or not? So AWS will identify the record, will provide you the lowest latency for your particular location based on tags. So whatever the tag that you provided for the record, it will pre-configure the latency to that particular record having that tag and routes your traffic to that particular record where it provides you low latency. So based on the tags, it will store your latency configurations on AWS. So in tags, what you need to provide is you need to provide region. So based on every tag, it will store some particular analysis of data regarding region and it will send you the traffic based on that. Does this latency routing policy supports health checks? Yes, it supports health checks as well. Health checks as well. If you are expecting multi-value answer, if you are expecting multi-values as returning answer for your query, then you need to use this multi-value answer routing policy where this will returns multiple this will return multiple responses from healthy from healthy healthy records. From healthy records, it will send multiple responses back. So in this, how many IP addresses will send the healthy records, sir? So actually, if you use this multi-value answer routing policy, then up to 8 IP addresses will send you the response back. So up to 8 healthy IP addresses healthy IP addresses will be considered. Up to 8 healthy records IP addresses corresponding IP addresses will be taken into consideration, and so based on the request you provided, you got the response written from the multiple healthy records. Among these only healthy records will send the response back. So these are the different routing policies we have. Based on your requirement, you can choose any one of the routing policy which best fit for your need and requirement. So I hope you understood all these routing policies. I think this video is contentful and you understood some knowledge or recapped some knowledge regarding Route 53 routing policies. If you feel this video is contentful, then please like, share, subscribe and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys.